Hello!
Hello, everybody.
We're back this week again, and this week we've got a very exciting stream for everyone. Finally, the long-awaited launch of Quinly for Prusa. So, are you excited, Leah?
I'm excited.
Excited. It's the same three of us again as it's been for the last couple of weeks. Myself, Mateo, co-founder of 3DQ. We've got Leah, one of our engineers, and then behind the camera we've got Steven, also one of our longer time engineers and product manager for the Quinly. Yeah, I guess let's just kick it off. What is Quinly for Prusa? So for those of you who are just learning about Quinly, it's an automation suite, including hardware and software, that is an upgrade to your existing machines. Prusas were made for Quinly
Yeah.
because they're so tightly engineered, and I think this whole stream is going to be a bit about like how Prusas are really good, but what's awesome about them as a platform for Quinly is that they have a lot of standard kind of sensors and calibration tools built in that makes them easy to operate, and that's why a lot of people invest in Prusa over an Ender. And then what's really interesting and what we'll dive into is how Quinly makes use of those tools and automates them in order to run your printer for you as you would. Quinly is basically taking your place as an operator, and all of that time that you spend calibrating the machine and running the machine, removing parts, scheduling parts, Quinly will take that off your plate. And we've been developing this since December, and like it's a big team developing on it. And what we've spent these last months doing is highly integrating Quinly onto the tools and sensors that Prusa gives you so that you get a very, very consistent and reliable experience using your printer. And I think as we go through, a lot of this will resonate with Prusa owners investing a little bit extra into their printer so that they don't have to deal with all the headaches that might come with lower end machines. The Prusa, the really exciting thing that we've done is we only use one version of firmware, and it's the MK3 firmware or the MK3S, depending on what printer you have, and it runs off the official Prusa version so that you don't have to worry about modifying configs, which we know, and just speaking to our beta testers, modifying firmware configs on a Prusa can be a bit of a headache. Here's actually the Pi image install. So there's this program that we link to in the manual called the Pi Imager. You just go in there, you select the image that we provide with the kit, you hit write, and then that'll write it to the SD card that's included with the kit on your computer. I mean, yeah, and that's pretty much it. You close it, and then you just put your Wi-Fi credentials on, save it, throw it onto the SD, and drop it.
Yeah.
There we go. That's pretty much it. Just all you have to do once you built the kit is connect it up, and it'll show its little Wi-Fi thing on the LCD. We've spent a lot of time simplifying the install so that you can save more time running your machines.
How does the build plate work? Do you adhere it still?
What we found is that the Prusa's magnet system is strong and consistent enough with spring steel plates that you can actually adhere the vapor bed to one of these plates without risking it moving during heat up cycles, which is typically the problem with other print surfaces and other like magnetic build systems. The repeated thermal cycling would cause it to move, but because of the way the Prusa is set up with the magnets underneath the heated plate, there's much less risk of that. And in our testing, we found it to be consistent enough that you can just put the vapor on any sort of spring steel plate. So that is now the recommended install. And for those of you asking about whether the inductive probe still works with the vapor on top of it, it does. There's plenty of clearance. The vapor surface is quite thin, and we've made sure that it works with the Pinda and Super Pinda probes. One of our customers, Jeremy Owens, we've spoken about him before. He uses Ender, but it's kind of this story of how Quinly changed the way he printed. He was using an Ender to print custom display mounts for tools, like power tools for sales. And he found that if he had these 3D printed displays in his truck, since he installed them, his sales increased fourfold, which is pretty amazing. And so he's been trying to outfit as many trucks with these custom displays as he can. But if you know anything about like power tools, there are dozens and dozens of bits and dozens of different tools that you have to support. So he was printing a lot of parts. And before he got Quinly, he was using an Ender 3, and it took him about a year to print 200 parts because he wasn't at home, he was always on the road, and so he'd only have a couple days a week to work with the printer and print those parts. But since he got Quinly, he's managed to exceed the previous year of printing in 2 weeks. And you would think, well, I mean, that's awesome. He's been printing 24/7. But what's really interesting is you would think somebody as busy as that, who's only got a couple days out of a week to work on their machine, wouldn't really have time to run more than one printer. Since then, I think he's purchased 2 additional printers, and that's because not only did Quinly increase his throughput by being able to run it 24/7, but it reduced the amount of time he had to spend with the machine, so much so he now had time to run 2 additional printers. I like that story a lot because it's a demonstration of just how much of a bottleneck a human operator is when it comes to running 3D printers. And this is obviously something, when I started working on Quinly 5 years ago, something that I noticed immediately and wanted to start working on. Some of the consequences of automating are very non-obvious, and you actually end up saving far more time than you think. So what we've done is added these ramps here so the parts can't fall through, and then we've also got this plow, so when the nozzle guides the part forward, you can see that in no circumstance is there really a hole except for at this most extreme forward position. Mm-hmm. And one of the fixes that we came up with, one of our beta testers, was this front incline that guides the parts off to either side. And so since we've installed it this way, we haven't had any parts kind of get jammed in here or stuck anywhere in the printer. We've really tried to think about like every possible failure case. Where can things go wrong, both physically and in software? And how do we make sure that Quinly delivers on a very, very reliable experience? Because if the kit was not reliable, that would only cause more problems in the end. Quinly is designed in a way to improve the reliability of the already very reliable Prusa printers. Okay, so I'm just going to do the Z calibration. Okay. So as Steven mentioned, it levels right through the vapor bed. This is one of those built-in tools that Prusa provides that we were talking about. So now we can do our Z adjustment. And this is identical to how you would have done it when you first got your Prusa. Sending the print then. All right, here we are. Here it is. Idle in its idle form. Here it goes.
Let's go.
Oh.
That was a beautiful release.
Right in the middle of the plow.
There we go. Cool. Beautiful.
I think that's pretty much it for the stream. Thanks for joining us. Yeah, and we'll see you all on Monday with the multi-day print challenge, which I think is going to be really fun. So look out for a very short stream on Monday where we'll be distributing the challenging part. And I'm really looking forward to seeing everyone's results with that.
Me too.
Yeah, if you have any further questions or want to talk to any of the development staff, join our Discord or send us an email at info@3dq. Someone will respond pretty quick. Yeah, or if you just want to have a discussion about it. The Discord's also a great place to connect with the rest of the automated printing community. Cool. It's nice talking with you guys as always. Talking. All right, we'll see you on Monday.
Bye.